So we are going to start some new stuff where we are talking about products of exponents. So we're going to learn all these different kind of properties or laws of exponents. And the first one we're going to talk about is called the product rule. Well, if you hopefully remember, the word product means to multiply, right? So what happens when we are multiplying terms that have exponents? And how do we deal with them? So first let's talk about what the difference is between 3x and x to the third. Okay, so 3x right here, right, this first one is different from x to the third. 3x, right, is like saying 3 times x, right? The number 3 times x. Whereas this one, x to the third, is different than that, right? It is not saying x times 3. It is saying x multiplied a number of times, right? The same number multiplied through. So it is repeated or multiplied 3 times. So x to the third is like saying x multiplied 3 times. And I know that seems kind of like the same thing, right? 3 times x and x multiplied 3 times, but it's actually very different, right? Because if x is 5, then we're doing 5 times 5 times 5, which would give me 5 times 5 is 25, and then times 5 again is 125. Whereas this one, if x is 5, that's just 3 times 5, which is 15, right? So we're dealing with the difference of 15 versus 125, right? So depending on what your x variable is, those can be very different answers. And just the meaning of them is very different. Okay, so we're thinking about what's different between exponents and just regular multiplication, right? Exponents are repeated multiplication, right? We're repeating the same multiplication over and over. So let's look at some examples. 2 to the second power and 2 to the third power. Well, 2 to the second power is like 2 2's, right? It's 2 times 2. You see those first two right here. So these two, x to the second, go with these two, right? 2 times 2. Well, let's think if we have another set, right? Well, x to the third, or 2 to the third in this case, would be 2 times 2 times 2, right? Because there are 3 2's there. But we're multiplying all of them, right? This is repeated multiplication, 2 times 2, and this is repeated multiplication, 2 times 2 times 2. And then we're saying multiply those. Well, we're multiplying everything, right? So it's 2 times 2 times 2 times 2 times 2. So total, how many 2's do I have? Well, I have 2 2's plus 3 2's gives me 5 2's. So total, I have 2 to the fifth power. So 2 times 2 times 2 times 2 times 2 is 5 total multiplications of the number 2, or the base 2. Remember, this big number is called the base. The 2 is the exponent, right? The big number is the base and the 2 is the exponent. This only works because these bases are the same. If I had different bases here, I could not put them together. I could not say that 2 and 2 and 3 and 3 and 3 is equal to 5 something, right? I couldn't say that. So making sure the bases are the same, we have 3 to the fourth and 3 to the fifth, right? So we have 3 times 3 times 3 times 3. That is my 4 multiplications of 3. And then I also have 5 multiplications of 3. So think about how many total I have. I have 4 here and 5 here. So total, I have 4 is multiplied a total of 9 times. Same for the next 11, right? And again, I'm going to run out of space here if I try to write all these, right? 11 times 11 times 11 times 11 times 11. It's kind of annoying to do it this way. But just so you understand what's happening here, right? Here's my 6 11s. And then if I put another 8 11s over here, I would have a total of 6 plus 8 11s, which would give me 14 total 11s being multiplied. So I would get 11 to the 14th power. The next one, I've got 3 terms, but they all have the same base, 5, 5, and 5. So I have a single 5 times 4 5s, right? Because 5 to the fourth is like 4 5s, and then 5 to the third is 3 5s. So total, I have 1, 2, 3, 4, 5, 6, 7, 8, or 1 plus 4 plus 3, right? Which gives me a total of 8. Okay, so I have 5 multiplied 8 times, or in other words, 5 to the 8th power. It doesn't change when I have a variable. I have x, right? Here's x to the ninth and x to the seventh. Well, that would be x 9 times, right? And x 7 times. Well, total, how many x's do I have, right? I'm multiplying all of these. In the middle, I'm still multiplying this times this. So these are all multiplied, this is multiplied, and these are all multiplied. So it's 9 plus 7 should give you 16, right? So I get x to the 16th power. Don't get confused when you have a number in front of your base, right? My base is still x, right? My x is the number with the exponent. X is the number with the exponent, but I have a number in front. Well, they're still being multiplied, so the coefficient, or the number in front, -2 times 4 gives me -8, right? But then I can think about my x's. I've got 3 x's and I've got 5 x's. So total, I have 8 x's, right? I have a -8 in front of them, but I still have x to the 8th power, because I had all these x's together and I've got 8. The second to last one always throws students a little bit, they get a little bit confused on this one, okay? But let's write it out as we did with these ones. This one here is a single x, and this one is 6 x's. So just by looking at it, how many x's do I have? I have 7, right? I have 1 is the first plus 6 of the other, which gives me 7. And you might be saying, well, this one doesn't have a 1 on it. It doesn't, because we don't write the 1 on an exponent, but all numbers actually have an exponent of 1. So if I gave you a really long, weird example, right, of a bunch of different terms, like let's say I have x to the, or I have -2x, y, z, right? This -2 actually has a 1 exponent, okay? This x has a 1 exponent. This y has a 1 exponent. This z has a 1 exponent. But I don't write things that way because it would get really annoying after a while. We assume that it's a 1 exponent if it doesn't say anything else. So when it doesn't have an exponent, that doesn't mean there isn't actually a invisible 1 there. So we have to add it together with the 6 of the second term, and we get 7. So we get x to the 7th power. And then this last one, just because it has parentheses around it, it's really just saying 2y to the 6th times -8y to the 2nd, right? I'm multiplying these two terms by each other, just like I was up here, except for this one they used a dot, and this one they put them in parentheses. Well, I have 2 times -8, which gives me -16. And then I have 6y's and 2y's, right? So I have 6y's and 2y's. Okay, so total 6 plus 2 gives me y to the 8th, and my number in front was a -16. So hopefully you're seeing how to do these, that they're really not that tricky. We're just kind of going to learn some of the laws of how to deal with exponents. So let's write a rule for what happens when you multiply two exponential expressions with the same base. All right, so what happens? We add, the rule is add the exponents. All right, well, what does that look like in an algebraic rule? So here's the algebraic rule we're going to talk about is a to the n plus a to the m is equal to a to the n plus m. Because this would be a number like 6, and this would be a number like 2. So when we get the final result, it would be 6 plus 2, which would be 8. Okay, so just a way to represent it in algebra. All right. Now, going on to something a little bit more for just a second. Let me make sure I've got time on my video. Yes, I do. Okay, so the products rule, okay? When we have a distribution of something to the products inside. So we're looking at something like this, where it says 2 times 3 to the 3rd power. What that's really saying is 2 times 3 times 2 times 3 times 2 times 3, right? Because this whole thing is getting repeated 3 times. So let's look at what we actually have, right? How many 2's do we have? They're all being multiplied still. I have a 2, a 2, and a 2, right? And then I have how many 3's? A 3, a 3, and a 3. So total, I have, you can see it written right here. I have 2, 2, 2, right? And 3, 3, 3. 2, 2, 2 were my yellow ones, right? And 3, 3, 3 were my orange ones. Well, let's rewrite that as an exponent, right? This is 2 to the 3rd because it's 3 2's. And this is 3 to the 3rd because it's 3 3's. So writing it again would mean that I have 2 to the 3rd times 3 to the 3rd. Well, what happened there? the third power basically got distributed to each of the terms, right? I had a 2 to the third and a 3 to the third. So again, you can write it out as a repeated multiplication, the number of times that you see it. That's what's really happening. And think about, oh, this is saying 4 times 6, but I do it 4 times. And then I can think about, well, that's really just 4 times and 6 4 times. Or I can think about that 4 exponent basically gets distributed to each of my terms inside the parentheses. So that's 4 to the 6th. I'm sorry, 4 to the 4th. Look at me talking. And then 6 to the 4th. All right, so what would happen here? If I'm thinking about it as distributing my thing, I can do it a little bit faster, okay? But really, this would be xy, xy, and I do it 5 times, right? xy and xy. And over here, I'd have 5 x's, and I'd have 5 y's, right? Which would be x to the 5th and y to the 5th. So let's make the jump and not write these out next time, okay? Same thing. It's 2 goes to the 3, and 2 goes to the 4, and 2 goes to the 5. Okay, so let's skip the middle, the writing out, because that takes a long time, right? And so we're going to write 3 to the second, 4 to the second, right? And 5 to the second. It's all 3 of them have a second power. Be careful in ones like this because you guys don't typically think of these as 2 separate things. A lot of students just want to take that 6 and give it to the x, but the 3 is also a part of this problem, right? This is really saying 3x 6 times, right? And if I wrote it out, I don't even have enough room, right? That's only 5 times. I'll write it one more time, right? Which is 3 6 times, and then x 6 times. So I have 3 to the 6th and x to the 6th. Okay, so why do you think they call this the distributive rule? Because you distribute the exponent to each part. Just like when we multiply, right? We distribute the term outside the parentheses to the terms inside the parentheses. All right, so let's come up with an algebraic rule thinking about this. Let's say we have A and we have B, right, to the n power. Well, that is equal to A to the n power times B to the n power. Because think, we took the A and we gave it n power, and we took the B and we gave it n power. And so we can distribute exponents as well. So hopefully